Good morning, Year 10. Apologise if you hear some noise in the background. I've got my dog next to me and he's chewing a frisbee. So you could hear some weird sounds throughout this, and you've just got to know it's a dog and he's very happy with a frisbee. So today we're going to continue with our 3D shapes, and we're going to kind of start off with this one here. So last time we talked about shapes, we talked about volumes of prisms. Now again, this is a prism. You'll see the cross section of it is a trapezium. Now for your starter today, I'd like you to try and find the volume of that prism. Okay, so pause the video, and if you need to look up the formula for the area of a trapezium, then do so to help you answer this question. Okay, so pause the video and off he goes, and find out the answer for me, okay? And then, the answer will be at the end of this video. So today's date and title are up here, and today we're going to be talking about volume and surface area of cylinders. So today's lesson is going to be all about cylinders. So write your date, title, and learning objective, and there are some important kind of formulae down the bottom here in the bullet points that you can write down. We know the top one, the volume of a prism is the area of the cross section multiplied by the length. Well, for the volume of a cylinder, it's the area of the circle, as you can see here, area of the circle at the front multiplied by the height of the cylinder, and that will help you find the volume. Okay, so write that one down and pop it in a highlighted box, as we usually do in class. Remember, pause the video at any point if you need to take some more time to write things down. So here's your first example. Now you can just make a few rough sketches of these. They don't have to be perfect, all right? And what we're going to do for each of these, we're going to find the volumes of the cylinders or of part of the cylinders. So I hope you'll remember how to find the area of a circle, and it's pi r squared. Now r we know stands for the radius, and the radius is the distance from the centre of the circle to the outside of the circle. Well, that wasn't very good, was it? But we'll just go with it. From the centre of the circle to the outside of the circle. And then we know that obviously the diameter that also we might be given as kind of a red herring is the whole way across. All right. So let's start with the first one. Now, you will need your calculator for this lesson, so keep it handy. I'm going to obviously be doing these examples, and I'm going to be using my calculator here. So the first one, we know the radius is 5, and we know the height of the cylinder is 9. And we want all of these to one decimal place. So what we would do, our volume is going to be pi r squared multiplied by the height, okay? And we can just substitute those values in. So V is going to be pi 5 squared times by 5 squared times by 9. And we can just type that into our calculator with times obviously in between each of those. So pi times 5 squared multiplied by 9. And that gives me 225 pi, which if we wanted to, we could leave it in terms of pi if the question wanted us to. But this time, obviously, we're going to be doing one decimal place, so press SD. And I get 706.9 centimetres squared. Okay, so that's that first one. Now I'm just going to talk you through the other ones. Actually, no, I'm not. I'm going to scroll down and do things. So the next one that we're given is in metres, so we know our answer is going to be in metres squared, and we can see that actually we're given the diameter here instead. So the diameter here is 7 metres, so what does that make the radius? Well, the radius has to be 3.5 metres, yeah? So that's what we're going to use instead. So for the second one, the volume would be pi and then 3.5 squared, and then multiplied by the height, which is 7. Okay, and if we sort that out on our calculator, so pi times 3.5 squared times by 7, I get 343 over 4 pi, which if we press SD, we get 269.4 meters squared. Okay. And then if we come up and have a look at this last one, you'll see it's kind of, it's half of a cylinder, isn't it? It's like a cylinder's been chopped in half. And now they do give you the radius for this one, which is good. So you just literally need to substitute it in. But what are we going to have to do at the end? Once we've got our volume of our cylinder, our full cylinder, well, we're going to have to half it, aren't we? Now you can incorporate that half at the start if you want to, or you can just do it at the end and divide by 2 at the end. It actually doesn't matter. What I would suggest is probably just whatever makes sense to you. Okay, whether you want to just put it in the formula at the start, because you could say the volume is going to be half times by pi times by 3 squared multiplied by 6. Okay, so that is incorporating the fact that you're going to divide by 2 and it's half of a cylinder at the end. I mean at the start, that's incorporating it at the start, okay? Or you could just get rid of that, do your usual pi times 3 squared times by 6 and then divide by 2 at the end. Okay, up to you. If we go back and do what kind of I said we were going to do, so half times pi times 3 squared times by 6, and we pop that into our calculator. So a half times by pi times by 3 squared times by 6. We get 27 pi, which to 1 decimal place is 84.8. And it's centimetres squared, isn't it? Now, I apologise about the complete lack of presentation of this. Remember, I'm using my finger and I've got limited space here. That doesn't make sense at all, does it? I'm just going to kind of section bits off. So that was for number 1. This all was for number 2. And then this was for number 3. I do apologise. What a work of art. Lovely. Okay. I do actually have it written down much nicer. And the answers there as well. Here. Okay, so if you want to use that instead and kind of adapt it yourself to make it look much nicer, then please do. Okay, let's talk about the surface area now. Okay, firstly we're going to think about the surface area is obviously the area of all the surfaces of a cylinder. So you're going to have your two circles, at either end. And then you've got that curved edge that joins those 2 circles. Now, if we really think about it, this length here is going to be the same as that length there. Therefore, one of the sides of this rectangle in the middle is going to be the circumference of the circles, obviously, because it's got to fit round both of the circles to join them up, and then you've got the height that would be in between them. So this length here is your circumference, and then you've got the 2 circles at either end, and that's the height given there. So let's think about that. Well, we know how to find those 2 circles. It's just pi r squared, and then you'd multiply it by 2. And then let's think about that curved edge there. Well, we'd have to find the circumference and then multiply it by the height. Now, your circumference is just pi times diameter, or pi times 2r, pi times twice the radius. Now, they've kind of summed it up quite nicely here in a formula. So the surface area of a cylinder is 2 times the area of the circle plus the area of the curved face, which is 2 times pi r squared. So that's 2 times the area of the circle plus 2 pi r h. The 2 pi r h is the circumference. No, sorry, the 2 pi r is just the circumference, and then the h is multiplying it by the height. So you get that area of that rectangle. Okay, so firstly, number 1, you must to find the surface area, you must firstly find the area of one of the circles and multiply it by 2. That's where this bit comes from here, okay? And then the second part, you must find the circumference. So 2 times pi times r, and then multiply it by the height. So it's kind of the surface area of a cylinder is split into 2 separate things. Now, please write down this formula here, and I hope you understand where each of those components of the formula comes from. Now, we're going to do an example, okay? So example number 2, calculate the surface area of the following cylinder. Now, we know that the volume is going to be 2 pi r squared plus 2 pi r and h multiplied by h. Okay. If you want to, you can literally just substitute those in. Actually, in fact, that's what I'm going to do. So the volume is going to be 2 pi 3 squared plus 2 pi 3 times 7. Okay. Now you can just chuck that into your calculator. I would use brackets to separate between the plus sign. So I open bracket, 2 times pi times by 3 squared, close bracket, add, open bracket, 2 times pi times 3 times 7, close bracket. So I'll write to you what I have in my calculator. So 2 times, there's my pi, times by 3 squared, and then close that bracket, and then plus, open the bracket, 2 times pi times by 3 times by 7, and then you close the bracket. Okay, and that's exactly what I've got written in my calculator. And I'm going to press equals, and I get 60 pi, okay? Equals 60 pi, which, you know, we could have worked that out absolutely fine without a calculator, because we've got 2 times pi times 3 squared, which is 18 pi, and 18 pi plus 42 pi, which would give us 60 pi. So this could well be a non-calculated question if they asked you to leave it in terms of pi. If you didn't, and they wanted you to find it to 3SF or 1dp or whatever, well, 3SF would be 188 centimetres squared, and you put 3SF in there. If it was 1 decimal place, it would be 188.5 centimetres squared to 1dp, and so on. So you get the idea. Now, here are the questions I'd like you to do. So on page 307 is exercise 15.2S, I think it is. And I'd like you to have a go at question 3, 4, and 5. Okay? Now, follow the instructions very carefully. Don't do anything that you shouldn't be doing. So question 3. What you want to do is question 3 is just asking you to find the curved surface area of the cylinder. So it's not asking you to find the total surface area of a cylinder. What I might just say is scrap that and just do this bit here. So it says use the formula total surface area of a cylinder is that to find the total surface area of each cylinder in question 3. So that would be good, so you can find the just the surface area of these. Don't bother with finding the curved bit and then the total surface area, because that's just, you know, may as well do both at the same time. And then question 5, I want the volume and the surface area of each cylinder. Now be careful as to whether you're given the radius or you're given, oh, actually, I think for all of these, they've been very, very nice. Look at that. For each of these, they've given you the radius for everything, so you don't have to be careful. But then look at here, be careful with units in part D. You've got 1 in millimetres